think I always need to click one more time. So I did this before and forgot to record. So we're recording. We'll share this with the class of any questions we come up with. So who would like to ask the first question?
I'll ask some questions. So they're actually very basic testing housekeeping questions. I
Okay.
noticed on the requirements for testing that we should show our ears, and I wear hearing devices. Do
Okay.
I need to take those out, or that's a different requirement?
No, that's just to see if there's like earbuds, like the Apple earbuds or something that some people wear during those, and those are not allowed, but hearing devices are.
So do I have to show them to the proctor?
Um, just show your ears. The way it works is if the unlock system feels that it needs to, they may have a proctor pop in, but if you're just usually in the what do they call that, the room scan, where you're checking all that stuff, you're just showing that your ears have um,
No earbuds.
yeah, they're not earbuds. That's all.
And the other thing is we are allowed to use our Desmos calculator.
Yes, that is the one that is allowed. There are some instructions. Typically, it's I think recommended that you open it before you open the exam, so then it'll be in a tab. Um, I don't have, since I don't have a student account, I can't actually go in as a student to see exactly how it all works. But there's a PDF
Yes.
that they provided us. But yes, you can use the Desmos calculator on any of the questions, regardless of whether Alex provides a calculator or says it's a non-calculator question. It doesn't. You have access to the Desmos.
Great. Thank you so much.
You're welcome. You're welcome. Okay. Let's get this tutorial. We're ready to go, and we can jump into any of the. What I find is usually it's the any of the reviews are the best review. Are if the reviews, if the question is in a review, that's where the exam gets its pool of questions. So it pulls from there. Uh, there's usually two or three for a particular, and it will randomly choose between those. So everyone gets a slightly different exam, but the same, tested on the same content. But if a question is not in the reviews, it will not be on the exam. So the reviews are a way of narrowing down what's going to be tested on, rather than looking at all the topics. So did any of you have a particular question or area you wanted to look at in one of the reviews, either 1347, 811, or 1214? And I guess while you're thinking through that, I also want to highlight that because some people, and again, this being recorded, so others will see it too. There are solution videos to all of the topics, the general topics in the reviews. Now, when you each time you do it, you get a slightly different question, right? The topic is the same, but the questions, there's multiple questions in there. So if you click on any of the reviews, um, you get a verbiage of why it's important, how, and what I just told you about the topics for the exam come from the reviews, and then each of the questions in the review, like for this one, have a solution video with it. There is also the listing, the name of the topic. So if you wanted to, you could go back into Alex and work multiple examples and stuff by going in through the review, or pulling up this specific topic outside of a review. But each of the reviews have it. This semester we have have solution videos to all of them, so you can always go back to that as well. But today's kind of like, if you've hit up on some that are just that you'd like to see, then that's what we're here for today. Oversimplifying and expanding logarithms, certainly. So that will be the topic in the 12-14 review. And I could, before we get into it, let me just do a quick review. Yeah, we'll go with blue. So for logarithms, there are, let's call it, I'll call it 4 basic rules that we use. The first one is that logarithms come from exponentials. So if we have an exponential, this is the base of the exponential. This would be the input to the exponential. So some number to an x, that's an exponential function, equals, say, y. The first thing we can do is we can change an exponential into a logarithm, and actually these work both ways. So the base of the logarithm, the base of the exponential over exponential growth. Sure, we'll do those next. The base of the logarithm is the base of the exponential. So the b goes down there. Because this is an inverse function, the two things that we're operating together separate. So the exponent goes to the other side, becomes what it's equal to, and the thing that was the output now becomes the input into the logarithm. So that's one thing we'll be using. And generally, notice how we basically solved for x with just that move. If you watch some of my videos, I tend to call this the log dance, because it doesn't feel like a calculation. It's just moving the things around, and that's how it works. And so since logarithms come from exponents, if we have x squared times x to the third, what do we do with the exponents? We add them. So when we have a logarithm, that it's kind of a little different, but if we have two logarithms of any base, say base 2, of a plus b, when we're adding them, they condense down into a single logarithm that is multiplication. Okay, so that's one property. So yes, this is one property, another property. The other one comes from division. So if we had x, say, to the third divided by x squared, that's when we subtract the exponents. 3 minus 2 gives us x to the first. So with logarithms, what that looks like is if we have log base 2, say, of a minus log base 2 of b, then we get division. Okay, and they also work, again, they work both ways. So when we go this way, it's called condensing into a single logarithm. And when we come from the other direction, then that's what's called expanding. And I'll do one more, and then we'll get into an example and see how that does. The last one is if we have an exponent raised to an exponent, what do? We multiply those exponents. So 3 times 2, this would be x to the 6th. With logarithms, what that looks like is if we have a log base 2a, say, to the 4th power, the exponent can come down in front and become multiplication. So this changes to 4 log base 2 of a. Okay, so that's the third and the fourth properties. So those are the properties we'll use for this. I'm going to delete that, and then we'll get into an example. Let's see. Come on. So maybe one like this. Would this work for you? Let's see, was it Durga? Okay. So we note what we've got going on here. We've got this divided by this, and then we're also going to have some exponents. But so this is a logarithm with, so to expand it, we're going to get 2 logs, and notice there is no base on this, but that means it's actually a base 10. But all we have to write is that this is going to become log base 10 x to the third, so this top part, minus log of the square root of x plus 6 to the 5th. And so we've done one step, but there's one more thing left, and that is we can bring the exponents down. And when we have a square root, what you have to remember, a square root is the same thing as a 1/2 power. So one thing, so we want to look at this square root of x plus 6 to the 5th as 1/2 times 5, because it's got a, so we've got a square root with the 5th power in here. This is going to be equal to 5/2, because you take 1/2 times 5, you get 5/2. So that's what the exponent's going to become. I'll write it down here. So this one becomes 3 log x. This one is going to become 5/2 log of x plus 6. And we are done because this is in a parentheses, so that is fully expanded. Okay, did that one help? Okay, good, good. And could maybe come back and look at another example if you'd like. Let's go to, what's that? Okay. It was, everybody's still there? I don't know what it's doing to me. There we go. I don't really want that. And then let me reshare. Okay. Where did my chat go? Okay, so let's go. Alana had asked about having issues with my, can we go over exponential growth problems? That'll be in the same area, I believe. Yes. Exponential decay. Okay, so let's find one in here that we can discuss. Continuous exponential growth. Okay, I think maybe the next one is exponential decay. They're similar. Let's see. Okay, yeah, radioactive substance decay. And basically the difference is that the exponent is going to be negative. It's something like this, Alana. Okay, perfect. So let's take a look at this one. And here's my, okay. So here, let's go with blue. And so radioactive substance decays according to the following function. So this is the basic, so it's continuous through growth, continuous decay because of the E. That's a natural number. We're asked to find the half-life of this substance. So what a half-life is whenever you have half the substance left. So they don't give us the starting value, obviously, and they don't give us an ending value. They give us a rate. If you'll see, this is actually, it's decreasing by, the way we read this is 6.2%. So 0.062 divided by 100 gives us, it's a 6.2% decay. Oh, yes, thank you. Let me clear this out. And think, see if it, oh, I know, I gotta change to my pointer. How about that? Is that good? I could even go a little bigger. Okay, perfect. All right, thanks for asking. Okay, so this gives us the amount, or the percent decay. Since we want the half-life, we can take anything for our starting value. Sometimes it's easier, like I could say, well, if I had 100, what would be half of that? That'd be 50. Or you could say, well, if I had 1, and again, why not, whatever it's equal to, once it's gone through its time period where it's its half-life, then the output's going to be half of that. So 1 and 1/2. So a lot of times people will use this, just plugging in these values, and then we can solve for t. So we get the equation that 1/2, because I'm plugging that in for y, equals y naught, which is 1. You don't really have to write this, but I'm going to put it there just to emphasize I chose that. Whatever you choose, like if you choose 100, then you would choose 50 here. So, and you'll see it all ends up, in the end, this is just going to be 1/2 e to the negative 0.062 t. And the way I go about this, so what's 1 times e? Well, or divide both sides by 1 if you want, so we can get rid of that. And we didn't even have to write that, but I did. Minus 0.062 t. Get rid of this, make it a little clearer. 0.062. What I would do now is, we've got an exponential with an exponent and an answer over here. I would do what I call the log dance, or changing the exponential into the log form. So e is the base on the logarithm, which is log base e, or you could just write it as ln, which I will do, but I like to emphasize that that's what ln is. It's log base e. E was with the exponent, so they're going to switch places. The exponent's going to be on the other side of the equal sign, and the 1/2 is going to come in and be inside the logarithm now. And again, on our calculator, we just use the natural log of 1/2. Do not round any intermediate, and round your answer to the nearest tenth. So they actually do want us to calculate this to the nearest tenth. So on some of these, they want the exact answer, so we wouldn't actually calculate the natural log. Minus 0.0. Plus the view of the problem. Thank you. I don't think I'm sure. I don't see the green around mine. You can see it? Let me just make sure. Oh, yeah, I'm sharing. Okay, good. Sometimes with Zoom, it goes like, at least, I don't know, I've got a Mac, it sometimes goes off screen and you have to click somewhere to bring it all back. But then sometimes it's my fault because I forget to share. So as long as some of you can see it. And remember, I am recording this, so we'll hopefully you can get it. Yeah, that also works. Okay, perfect. And so the last thing, or sort of the last thing to do here, is to just divide both sides by negative 0.062, divide by negative 0.062, This will cancel, so that will give us our t value here. And I'm going to show you what since our main calculator, we had some issues with people using inappropriate things, so that's why so let me show you. You can use Desmos, the graphing calculator, just like a scientific calculator as well. It's a little messy here, but see if we can get there. I'm going to come back to this. You can actually, what I'm going to do is I'm just going to type in this question or this calculation, natural log of 1 divided by 2, 1/2, and then that divided by negative 0.062. And notice it calculates it right here for me. So I don't have to go to I don't have to use the Desmos scientific calculator. I can use the graphing one, which we use for some of the other questions. It's very helpful, especially when we get into trigonometry, very helpful. And we were asked to round it to 1 decimal places, so that'll be 11.2. So then I can come back here and just put 11.2 days, and that would be our half-life. Okay, but it was a student that showed me that Desmos, I didn't know Desmos could do that. I thought it only would graph, but if you just put in a math expression, it will give you the answer right there. And this even has log base, so if you see, if we click down here to show the keyboard, you can go to functions, and maybe I should erase, I'll erase those eventually. If you come down to logarithms, you can put in logs with various bases. So you can put log base 7 if you need to, of 28, what, you know. But any function that you can do with TI-84 calculator can be done with this one, and actually it's a little nicer. So look at the functions. It does have everything down in here. And then, okay. Did that help out, Alana? Okay, great. And if you want to see some more, because there's different versions of things in here, and I'd be happy to take a look at anything. The goal is you're here, so that's what we focus on. You get to ask the questions, and I'll explain them in a way that hopefully makes sense. Let's see what else did this other. Thanks, Dakota. Okay. What else? Okay, we need a bigger exponential decay. We could also go take a look at logarithms. Sometimes it looks different going the other way. Yeah, like this one. And this one's a little, because it's solving for x, sometimes a little more complicated. What would you like to take a look at this one? Let's see. Okay, so let's take a look at this one, and then we'll maybe look at some more exponential decays. And again, remember these topic types, or the questions that are in here, are pretty. I mean, they'll be slightly different, but only slightly. So once we do one, you'll kind of see your test would have something like this. Okay, so for this one, let me see what I want to do. One option is when you're solving for x, if you can get a logarithm equals a logarithm, just a logarithm, basically the inputs are going to be equal, but we've got this extra +2 here. So what we're going to have to do is we'll move this logarithm. Let's see. We'll take this one on the left, we'll move them so that we get the logarithms on one side, and then generally there'll be just a number here, so then we'll probably do the log dance to solve it out. So what I'm going to do is I'm going to subtract the log base 2 of x plus 4 from both sides. And this is just whenever you subtract something from itself, that's always 0. So now we have log base 2 of x plus 7 minus log base 2 of x plus 4. These are not like terms, so we can, that's how we do that. And now it's equal to 2. You can see these logarithms, log base 2, since we're subtracting them, we can make them into one logarithm, log base 2, and when we subtract it becomes division, x plus 7 over x plus 4. So the one that's being subtracted always goes in the denominator, the one that's first goes in the numerator. Okay, not looking real pretty yet, and it actually doesn't get very pretty, but what we can do at this point is we can do what I call the log dance. This is the base of an exponential. Remember, logarithms are always equal to an exponent. This becomes the exponent, so this becomes 2 squared, and then the input becomes the output. So we're doing an inverse function thing. And it still maybe doesn't look too friendly, but 2 squared is 4, so let's do that part. And now what do? Well, let's multiply both sides by x plus 4 to get rid of this fraction. And we're just using the principle in algebra with an equal sign, with an equation. You can do anything you want as long as you do it to both sides. And if we do this on this side, x plus 4 divides into x plus 4 and gives us 1. Over here, we'll distribute the 4 to this binomial. So we have 4x plus 16 equals x plus 7. And we were fortunate enough to end up with a linear equation. Now we just got to get the x's on the same side. So I would subtract x from both sides. I'm going to bring it up a bit. So 4x minus x is going to give us 3x plus 16. This cancels and becomes 0 equals 7. We need to subtract 16 from both sides. We get 3x equals negative 9. Did I get that right? Sometimes I can't. Yeah, it must be negative 9. Then we divide both sides by 3. And we really have to watch our negatives and positives. Okay, I think sometimes that's where I get problems. So x equals 9 divided by 3 is 3, so negative 3. Now we could just put it in, but we always have to come back and check that it's an answer that can be used. Sometimes, one of the things we can't have inside of a log, say log base 2 or any of them, would be a negative number, even negative 1. It's not in the domain. So what I do is I check if I put in negative 3 for this x, am I okay? So negative 3 plus 7 is positive 4, I'm okay here. If I put negative 3 in here, negative 3 plus 4, that's going to be plus 1. I'm okay here. But if either one of these was a negative number, then or 0, negative or 0, because you also can't have zeros in this. So remember, for a logarithm, the domain x has to be greater than 0. So it's one of these things you always check back. Usually when there's only one answer, you're going to be okay, but there are some times where you'll get 2 solutions and one of them actually just doesn't work because it gives you that negative. Did that make sense? Or is it? Okay, good. And if it didn't, let me know, because it's just cannot, because that's one of the things I would always forget to do is check the, oh, I got negative 3 and negative 20. But notice we've put negative 20 in there, and I'm just making up the negative 20. it would not work because you can't take a log of a negative number. And we could come over here and watch as soon as I put a negative in there, we get undefined. Or if I put 0 up here, we're going to get undefined. So those are the things that don't work in a logarithm. So remember to check your answers. Okay, is that good so far? So that was one. Okay, that was one of the more complicated ones we would see. So combining logarithms with the rules and then solving. So that's not too bad. Let's see. We could, and again, if you want to jump to something else, we can do it. I'm at your disposal. This one's a very similar one. So you see how it is on these your test you'll probably either get 4 or 5, but you wouldn't get both because these are very similar. So some students will do 4, some will do 5. Again, one might be harder for you than the other. Let me just walk through this one maybe a little quicker, but logarithms are being added. So then we get the natural log of 5 times x plus 3, which you could distribute, equals 3. The thing you have to remember here, natural log has a base of e, so then we can do the log dance. This becomes e to the 3rd power equals 5 times x plus 3 using the log dance. Do not round your answers to the nearest hundredth. Okay, we can distribute the 5. So this is e to the 3rd power, 5x plus 3. Subtract 3 from both sides. E to the 3rd minus 3 equals 5x. And then divide by 5. So we get x equals e to the 3rd minus 3 over 5. And this is what they mean is I wasn't doing I could have done e to the 3rd up here, but then it's going to be this decimal. And so I just kept it all together. And what I'm going to do is I'm going to plug this all in here. This is supposed to be an equal sign. And just get that number. And then I will round it to the nearest hundredth, which is 2 places. Wait. Oh, thank you. Yeah, we got going too fast. Distribute 5 times 3 is 15. Thank you so much. Yes. And then again, when you get to the end, you actually, if you don't do the check, you should go all the way again. I don't always do that because 15, right? 5 times 3 is 15. So we're going to subtract 15. So I should have done a little more. So this is 15 and this is 15. And we can just enter this, and so this will give us a better answer. And let's just put e raised, and yeah, I'm just using my keyboard. To do the exponent key, you do a shifted 6. And then I arrowed over, subtract 15, and then we're going to, something I like about this, I'm going to divide by 5. And I got all the negatives and everything, so it should be 1 point in nearest hundredth, 1.02. So the 7 makes the 1 go up to a 2. Unfortunately, we can't check these until the end, but that's the practice. Did I get it all right this time? X. Oh, and it was x minus. Thank you. I didn't see the minus. See? Thank you. And again, this is why it's also important to include your scratch work when you're finished. because I can see copy errors. I said, oh yeah, you just did a copy error right off the start. And you can see that you knew how. So this was minus. It's going to make that plus, that plus, that plus, this plus. Okay. Yeah. That's the thing with math is you can be so close. You know, you're 95% right, but you get the wrong answer, getting in a hurry. That's one of the things, or one of the things I've really worked on is organizing the way I work through something. So 7.02. So now 1.02, 7.02 will be okay. All right. And that's why on the exams we do give you 2 hours. So even it's a midterm, but we still give you the 2 hours and the final the 2 hours with practice on these. The goal is that some students can get it done in about an hour, but you know, take the time you need, and the better you prepare yourself, the better it's going to be. Also remember, there is in here. Let's see if I go to assignments. Once there's a prerequisite on it, but they're locked right now because I'm in a review, so it won't let me go. But there is also one more, there's like a practice test in here. Where is it? Practice test modules 1 through 14. So this is the one, you have to have done some of the work in the last review for 12 to 14, which we're doing right now. Then this would become available. This is a 20 question sort of randomized practice test. So what that's there, I wouldn't do it, just say I'll do this several times and I'll be ready, but it'll help you know what kind of timing you need. You want to go through all these reviews multiple times, and that way you will have worked through all the types of exam questions you might get. But this practice there was requested by students. You can take it once. Actually, you can take it unlimited times, but once you take it, you have to answer all the questions, and then it does a complete retake for a new version. So it really is just this practice of getting your timing down and to get you in the mindset of the exam. It could be helpful to do it a couple times. That would be great, but also don't do that instead of doing the reviews. The reviews, if you go through each of the questions in each of the reviews, you will have worked all the potential questions you will face in a 20 question exam. Okay. Yeah, so let's go back because where am I? There we go. What else is there? Oh, good. See some natural errors that come up. What else would you like to see? And again, if you can just point me in a direction for either a question, and we can jump to another review.
So I do have a question, but before that, I wanted to kind of mention something that
Sure.
I found helpful that I just wanted to kind of, share. So
Perfect.
for the exponential growth and decay problems, if we have to solve or we need to find the rate or the time, if you go in the decimals calculator, I kind of thought about it like this. So you take the natural log and then in the natural log, you divide by the final number
Uh-huh.
divided by the original number, and then take that and divide it by if you're finding the rate, divided by time, and if you're finding the time divided by rate. And usually that kind of fastens the process a little. So I thought I'll share
Perfect. Yeah. And that's advantage is what you're saying is once you do these, you start to see the shortcuts that they're the patterns that they're always going to be that way, and that's great. Usually, it doesn't make sense the first time you go through, but you were able to do that because you saw that pattern, right? And that's excellent. Yeah. And what you'll see, one way of thinking like the half-life stuff, you always have that natural log of 1/2, and then you divide by the rate in front. Um, let's see. And I'm dyslexic, so sometimes I heard what you were saying, but sometimes those I get everything backwards. So I'm one of those that I have a hard time doing the shortcuts. I take more time, but let's um, let's see if we well, let's do this. We should be able to pull up another one that maybe is not the half-life question. I think that something like this. Let's see. We want with this one.
Yeah,
This
like that one, like that one.
like this one. Okay.
Yeah.
So
So how this would work is we know the what VT equals. Hold on, let me find it. Okay. So to find VT, we would have to minus by 82, I think, in order for this to get it to like where it needs to be before I
okay.
like what I need to do.
So get this 82 over to that side, and then you'd have minus 82 e to the minus 0.18 t. Is that right?
Yeah.
Okay.
Yep. So then if you go to the decimals graphing calculator,
Uh-huh. Good, it carries it over.
so you would do natural log, and we're going to take minus 82, and then I believe, okay, and then we divide that by the initial amount, which is also minus 82. I think. Um,
Um, so I divide this by negative 82?
yeah, you just kind of divide the final amount by the initial amount in the natural log.
Oh, okay. So you're saying this is the final and this is the initial. Okay. Let's see if this will.
And then you take that entire natural log and you divide it by the rate and you get the time.
Okay. That would make sense.
I think I might have read the problem. Can you go back to the problem? I just want to confirm because like I didn't write this down, so I might also be mixing this up. So let me just confirm. Yep, yeah, okay. Yep, that's how I do it.
After driving with the skydivers velocity. Oh, the one thing we're missing though, that's probably good, is so what's going to change here? How many seconds after diving will the skydiver's velocity be 67? So we know v of t is 67. I didn't read far enough to see it. So this would be 67. 67 minus 82 would give us 12 plus 3 is 15, negative 15. So 67 minus 82, negative 82 e to the minus 0.18 t. And what the reason it's working, I guess, is if you were to, we could divide by the negative 82. So this is what you're, right, that cancels out. Then we're taking the natural log of both sides. So that's where that comes in. And then we're left, when we take the natural log of something with e, that just gives us negative 1. So all the steps, and that's why all that's left is to divide by the rate. And like you said, if we had the time and we're looking for the rate, we would just divide by the time. But those kind of things of remembering the positions sort of advance sometimes. Yeah, I missed the 67 as well because yeah, we were getting set up too quickly and we had to read that there was a little bit more here. So that's 1, so t equals this. But the nice thing is we just come back here and we just have to change our 82 up here to 15. And now it's, so it'll, yeah, 9.44 seconds. I think they want the nearest hundredth, the nearest tenth. 9.4 seconds. But good, yes, that's exactly right. So once we plug in, there's, sometimes it's a little easier just to see the patterns than to go through all the algebra steps. But if you're not certain, algebra will also get you there. Okay, is that helpful? Can we see? Thank you. My pleasure. After this, can we cover word problems involving optimizing area by using a quadratic? Certainly. Let's see, that's probably back, it's not in here, so I'm going to submit and we'll check. Let's see if I got all these right. Or let me look at the report real quick, just so it's another, whenever I do the reviews, the red ones are ones we didn't do, hopefully, or I didn't put in the answer, I just wrote them out. But we did get 5, 9, and 10. I put answers in those, so that's good. But now that we've submitted this, we can, instead of retake, let's go to, no, not review. Let's go back. If you go into review, you can go back to specific topics that you would like. I think quadratics is at 8 to 11. It could be 4 to 7. I think we've got some quadratics in here. I'd have to go back to 4 to 7. These are polynomials, word problems that become quadratic, something like this. This is going to be a cubic. I'd be happy to look at it. What you'll see is there's that box problem, and actually, maybe that's it. I thought there's another open box problem. Typically, you get one or the other. No, that's so that's. I think we're going to have to go back for quadratic because these are getting into rational functions. Yeah, the pizza box one. Yeah, so okay. It's not my favorite one, but it's not too bad. It's once you see how to do it. And actually, it's I've used this one. I also teach the math for elementary teachers courses, and this is a really good one because you can actually take a piece of paper or a piece of cardboard, and you can physically do it, and that's when it starts to make better sense. But let's go ahead and label this one. Okay, so rectangular piece of cardboard with perimeter 17 inches. So that means all the way around it's rectangular 17 inches. 3 parallel and equally spaced creases are made. So there's your spaces. The cardboard is then folded along the creases to make a rectangular box with open ends, letting X represent the distance in inches between the creases. Use the Alex graphing calculator, so you could, or we can use decimals to find the value of X that maximizes the volume enclosed in this box. Okay, so what we know is it's 17 inches all the way around. We know this side is 1, 2, 3, 4 because of the drawing. It's 4x. So the length of this side is 4x, the length of this side is 4x. These sides are, so when we think of perimeter, if you add those sides together, 4x plus 4x, if you take 17 minus that, that gives you the rest that is available for the other two sides. So you've got to divide that by 2. So I'm just gonna call this side y. This would be the same y, and what y is it's this this length. So it's going to be 17. 4x plus 4x is 8x over 2. That's going to be y, which as you see is when they fold it up, that's going to be the length of this side. But it's now in terms of x, because we don't know what y is, but we'll figure out what x is. We need to get it down to one variable. So it's 17 minus 8x divided by 2. Actually, I think we end up with no, we're going to end up, because we're doing volume, we're going to end up with a cubic. But so that was the basic thing we had to do here to set up this. Does this make sense, this number I got here for the length of this side? Kind of. Okay, so one way to think of it is that we know the perimeter 17, so if you add all the sides together, 4x plus 4x plus y, because 4, so that gives us that 17 equals 8x plus 2y. And then what we want to do is solve this for y, because y is something we introduced. We could have called it anything we wanted. So we subtract 8x. But this is just kind of taking the definition of perimeter. 17 is equal to all the sides added together. You get 17 minus 8x equals 2y, because we're adding those together, and then we divide by 2. So y is equal to this. Okay, all right, good. And then for volume, it's length times width times height. And so this is a width maybe, this is a length, and this is a height. So it's going to be x, so volume is equal to x times 17. See, I almost did it there. Start writing a plus when it's a minus. 17 minus 8x over 2. And what we're going to do, we don't have to do any algebra on this. We're going to just put this into Desmos. We're going to graph it, and it'll give us a cubic equation. Cubics always have a, well, it's going to be a negative cubic, but you'll see we'll get a graph something like this. And what we'll do is this will give us the local maximum. Okay, so this is what we're going to graph. And I'll get rid of all that stuff in just a moment, but so I'm just going to do y equals, so this is because x and y is all we graph here, x times x, and you could do x squared if you wanted, but I'll just do x times x times 17 minus 8x divided by 2. We'll put that parentheses there, and then now we get our answer when we click here. So this is the x value is the width of each roll or crease, but the volume, the y gives us the volume is 5.686. Okay. So here we just, the value of x that maximizes the volume is going to be this x 1.42. How they want us to round it to 2 decimal places, 1.42, and then the maximum volume comes from the y value 5.69. Okay. That makes sense? Is that helpful? Okay. Okay, good, good. And so it's just kind of, that's the thing, is that you have to come back to your geometry, which for many of you, you may not have had it since middle school or even grade school. We don't spend enough time doing geometry. And myself, I was fortunate. One of my mentors when I was doing my math education back in my undergraduate, he would always tie algebra to geometry. He was really good at doing that. Always got us thinking about the geometry, which is so important when teaching too. So, yeah. Where were we going after this? Let's see, what time is it? As long as you guys want to stay here, if you need to leave, that's fine. But if you're here, I'll just keep going. The other type of cubic. Okay, let's see. Where was that? That was, find the zeros of this. Actually, this one you just have to graph it, and then you find where it crosses the x-axis, right? So there's that one. Let's see, where's the other cubic? The other one, the bigger box one. Yeah, that's a, maybe that's in the next review, or maybe it's down the road. Let's see. It's not there. It's not there. I know I put this course together, but I can't remember where everything is anymore. It's such a, and I've been working on this course for over 4 years. I think maybe 5 years I've been the coordinator, and I've got a co-coordinator, and very helpful, and but there is just so much to this course. So these are all logarithms. I think what we're going to need to do, I think it's back in the one just before this. I'll just do a quick check on the report. Make sure we got it right. Yeah, 3, we got it right. Okay, so let's go to the one for 4 to 7. I think it's got to be in here. And probably towards the end. Let's come backwards. Well, there's this one. I think this is one you were asking for about, because this will end up being quadratic word problem. Okay, so let's do this one, and we'll keep looking for the pizza box one. Okay, because then they all work pretty much. A school wishes to form 3 sides of a rectangular playground using 320 meters of fencing. So they're showing us here a side is along the school building. So they don't need fencing, obviously, because there's a building here. So I just go like, 3-dimension. So we need this side. There's an X here. And then this one, we don't know what it is, but we'll call it Y. And this is similar, right? We have 320 meters of fencing. So if we add all these 3 sides together, X plus Y, we will get 300. That's about to maximize. We're going to use the 320 meters of fencing. So this gives us that 2x plus y equals 320. Subtract 2x from both sides. And what we get is that y equals 320 minus 2x. Then what we're trying to do is we're getting the function that maximizes the area. Area is base times height, length times width. So it's x times y. Area, x times y. Again, we invented y. What is y? We're going to plug in this. So our function is going to be x times 320 minus 2x. And then we're going to distribute that x, and I'll try to be more careful this time. X times x is x squared, so we have a minus 2x squared. So that would be our function. Let's see if I can come down here a little bit. Our function here is 320 x minus 2x squared. Okay. And then what side length gives the maximum area of the playground can have? what we're going to do is we're just going to graph this with Desmos. They do provide the Alex calculator, so you could use that one. I like Desmos because all you have to do is click on the dot and it'll give you the answer. So we're going to put in 320x minus 2x. Let me erase this, and I think we'll be okay. 320x, actually I'll do y equals, which is a different y than I used over here. This is just kind of a, I guess I'd call it a dummy variable. We could have used anything. It was just holding a place so that we could get it all in terms of x, 2x squared. But now, did I get that in there right? Yeah. So we've got a quadratic, and just remember a quadratic, it's got a negative leading coefficient on the x squared. So this is going to be a quadratic that goes up and down. So we'll have a maximum. We see this going up here. 320 is pretty big. One thing you can do with Desmos, sometimes helpful, is it on this little tool here. If you click on that, you can resize the window. Let me get all this stuff out of the way because we've already done that part. So I'm going to go with the y-axis. I don't know, 320. Let's see. That's going to be big enough. How much is x going to be? Remember, x is the length of a side. Maybe it's 320 total. I'm going to go for 150 feet. And I'm still not big enough. So you can also, let's see, how do we can also zoom out. So I'm going to just kind of keep doing that. And the nice thing is, wow, it goes way up here. Did I get 320x minus 2x squared? There it is. And we just click there. So x should be 80. That's going to maximize, and the area is going to be 12,800. So the side length, they don't ask, oh yeah, they do. I thought they would ask for this. So that would be 80. And then what's the maximum area? 12,800. And you could kind of go back, and if you put in the 80 here, if you wanted to manually check, you could. But that's what the graph, that's why I like doing things graphically. As long as we put in the equation correctly, the equation will show us the maximum, and we've got it right there. Okay, is that understandable? Okay, let's see if we can't find that pizza box question, because it does have a little bit of a trick, but once you remember it, once you see that trick for it, or maybe I didn't put it in, I can't remember. I might have, no, the other one's a volume, so they're all going to be x cubes. I'm surprised it wasn't. Maybe I just have that one. I bet you what happens is that one topic probably has it has either the pizza box or the other one. It's a volume problem. So let's do this. I don't think we're going to find it here. I think if we go back though, we might get lucky enough to pull it up. And if not, I'll do one more thing. Did I submit that? I think I have to submit it. Yeah, submit assignment. So let's go back, and maybe if we look at it a second time, although I don't think it's going to show it to us because I got it on, yeah, it won't let us do it again until we work all the others, and I can't override that. Let's do this. Let me go into the practice test. Why not? We might have it in there. Where where did it? And all of these are like, you must complete the, okay, I thought I submitted that. Maybe a lot of times when you open it, because I looked at something, I've got to submit it before it lets me do anything. Because again, these are all built on the same platform as a test. And when you're doing a test now, it doesn't let you do anything else. Whether it's a practice test or an actual test. So let's, oh, I don't have the prerequisite for that. So see if, will it let me in? Oh, I need a score of 50%. Well, let's come back here. And the thing is that when I'm in student mode, I can't actually go back very easily and go to some of them because they're all locked for me because I haven't worked through them in my version. Let's see. I know what I can do. I can leave student mode, go do that, and get back into Alex. If I start it again, then I can reset it, and we'll just take a look and see if we can find that one there. So I'm going to, what do? I go to student mode. Student view, does that open up? Hopefully it reset it for me. Oh no, it didn't reset. Oh, I know what I need to do. Let's reset this. Okay. Almost there. So let's try this one more time, and it might still not get us 8. If not, I'll make up one from sort of memory how we could do that. That was question, is it 3? Oh, we got this box. So I can, yeah. This question has, if you're going to get a box question, you may get this one, the open box. You may also get the one with the lid on top. So let me go ahead and work through this one, and then I'll change it up, and we'll make it into a box problem from the same, and I'll show you the difference. Very similar, actually. Okay, so we've got this piece of cardboard, sheet metal. It measures 3 inches by 8 inches. So they've given us those here and here. The manufacturer then folds the metal upwards to make an open top box. And again, it's helpful if you actually just take a piece of paper, tear out these corners, and then fold it up, and you'll see you will get a box. What gets torn out, these corners are X on each side. So this length of 3, when we come over here to this box, it's now going to be 3 minus, notice there's an X on each end, you're subtracting off 2 X's. The length of the box is going to be 8, and you're going to subtract off X on each end, so this one becomes 8 minus 2X. And then the height of the box is just X. And then the volume is length times width times height. So volume is going to be 8 minus 2x times 3 minus 2x times x. And we don't actually, you could multiply that out, I suppose, but you've got a FOIL. There's no reason to, because the question is just asking us what is the value of x that will maximize the volume and what is that volume. All we need to do is graph this, and again we're going to get, this will be a cubic, we will get a graph something like, actually goes like this. We just need to find that point, and that will give us the x coordinate will be our answer for that, for the value that maximizes the volume, and the y answer is actually the volume. Okay, so let's but it's the getting it set up. It's just saying, okay, we're getting 2x on both sides, and we just put in y equals 8 minus 2x, 3 minus 2x times x. And now we kind of have to probably come back down. Or zoom in. Yeah, because the box is only 8 inches, so it's, let me just, sometimes when you mess around with this too much, we don't have to be anything more than 8 inches, and this actually could be 0, because you, remember this is the size of the cut. If you don't cut anything, you can't make a box. You certainly can't cut more than 8, probably can't cut more than 3, you can go down to there. And then for the y-axis, what the volume's going to be, I don't know, we'll go for 20 minus 20, actually 0. But you just have to be able to see the graph, and this sort of makes sense, remember, because if it's the shortest side is 3, the most, actually the biggest cut you could do is 1.5, because after you cut 1.5, you've cut both widths. So anyway, all we have to do is click here, it'll give us our maximum. So 2/3 of an inch, 666 or 67 if we round it to 2 decimal places, and the volume will be 7.4. And they want it to 2 decimal places, 7.41 for the volume, and 0.67 for the size of x. Okay, now let me, was that meaningful? Did that make sense, or were there any questions from that one? Okay, let me just show you, again, we'd have to get out, but the other one is what they do is they say, okay, we're going to make this into a pizza box, and so there's an extra cut along, let me get my pen, and the picture will show it, there's an extra x along here. So they'll cut a little, this little piece here, this x here. So the way it becomes, and then you get a lid, and notice the lid doesn't help the volume because it just covers it. And so the way this one would work, let's see if I can do this with that going over. So on the one end, we still have, notice this doesn't affect this length of 3. You're still going to get 3 minus 2 x's for this side. But when you make it into a box with a top, notice the 8, it's losing 3 x's. And then that length is going to get folded on top of itself, so you actually only get half of its, you know, this half gives you length that's part of the volume. The other is just a top that closes it up. The height of the box is still x, because that's the cut that, you know, whatever this makes your top. So that's how the box with a top, is different. Instead of just having 8 minus 2x, you actually got another x in there, and they show you on the drawing. So you'll see that there's 3 x's on this side. So just do the 8 minus 3x, but then remember, it's not as clear, but that half of that box is going to be a top. It's not going to go towards the volume. And so that's why you divide that side in half. And then these two are very similar. Um, is that helpful? Okay. And again, you're only going to get one of those, and but you would want to practice all of them, because if you're like me, you always get the one that you didn't. I won't get that one. That's the one you get. The one you practice 5 times, you don't get that one. You get the other one, and it's like I said, I don't control that. So, but practice them all, and they're just see how they're similar. All right. Almost 7 o'clock, but if you had another question or wanted to see something else, I'm here for you. Anything, or questions in general?
Not really for me. Thank you so much for this session. This was really helpful.
Wonderful. Thank you for coming. I would have been lonely without you all, so thank you. All right, and if you come up with something else, I'll be around, so just email me, and if you have a question before the exam, remember we do have a Friday suggested due date, but it is open until Sunday without any penalties. I don't believe in penalties, but I want you to think I want to give you enough time to start on the trig part as well. So that's why I kind of push Friday as sort of a suggested due date, but I know a lot of the students, myself included, we need the weekends to get work done. I'm still doing graduate work because I'm just a lifelong learner. But so I'm taking some classes myself, and I need those weekends. So I understand that. That's why we give those extensions. But just contact me if you need anything. All right. Thank you so much.
Thank you.
Thanks. Oh, I gotta stop recording.